Hello everyone. So this is our second lecture of module 4 and today's topic is surface integral. Surface integral, or you can say double integral. Clear? Okay. So in double integral means we have two integration. And suppose we have a function f of xy. We have to integrate this function f of xy and there will be some region, given region R, okay, dx dy. Now you have to remember some points. Points means here the region is R, so obviously there will be some boundary of x boundary, okay, there will be some x boundary and obviously there will be some y boundary. Okay, first point is when you are writing the limit of x, okay, the process is you have to take the limit from left to right. Okay, for limit of x you have to take the limit from left to right. Number 2, similarly limit of y, that will be down to up. Clear? So first 2 point is the first limit of x, that will be left to right, and limit of y, that will be down to up. Okay, now third point is suppose you have double integration and let's say first this integration is integration limit is y to y square and this integration is, let's say, 0 to 1. Okay, suppose we have any arbitrary double integration. This first integration is y to y square and this integration is 0 to 1. Now you have to understand which one is limit of x and which one is limit of y. Remember, if in any integration, if the limit is variable of y, okay, if the limit is variable of y, that means that limit of x. Clear? In the first integration, here the variable is y variable, so obviously first integration will be with respect to x. Clear? First integration will be with respect to x, so obviously the remaining limit will be, or remaining integration will be with respect to y. Okay, third point. Now suppose same question or same concept. Suppose the double integration is, this is x to, let's say, x cube and this is, let's say, 1 to 2. So obviously here variable is x, that means this is the limit of y, so this will be integration with respect to y and this integration will be with respect to x. Clear? Now one more point. Suppose the double integration is, suppose this is x to x square and this one is, let's say, 0 to 3. Okay, so obviously the first integration, this is the variable of x, so obviously this is the integration with respect to y and this will be with respect to x. Now remember, whenever you are calculating double integration, the first integration will be variable integration. Here the variable limit is x na, and here this limit is fixed limit. So remember, the variable limit will be your first limit. Okay, so obviously, and in this case this is dx dy, so obviously in this case you have to change the order of the integration. First you have to integrate the variable limit, then you have to integrate the constant limit. So you have to change the order of the integration. So you have to change in this way. This will be x equals to 0 to 3 and this will be y equals to x square f of xy, and this is dx dy na, and you have changed it, so this will be dy dx. Clear? If you are changing this order, so you have to change this order. Okay, if the first integration is dy, so the first integration will be with respect to y. Okay, and the second will be with respect to x. So you have to remember these 3 points. Remember, you will never get this type of cases where both the integrations are some variable limit. This is not possible. Let's say this is x to x squared, let's say this is y to y cube. This is not possible. There must be one limit with finite values or with some numerical values. Okay, this is not possible. Okay, so you have to remember this some points. If there is limit is variable of x, that means the limit is limit of y. Okay, opposite. If the second point is the variable limit will be your first integration. Okay, then the numerical limit. Okay, now let's solve some problem. And one more point that I already have told in my previous lecture, that when you are calculating the limit, okay, you have to take the limit, or you have to focus on the path, not on the coordinate of the point. You have to focus on the path. And if you are calculating line integration, then you have to focus on the coordinate. Okay, but today's topic is double integration. That means we have to focus on the path, so we have to take the limits depending on the path. Okay, so let's solve first question. First question, here given number 1, integration 0 to pi by 2, integration 0 to pi by 2 sine x plus y dx dy. Just simple example. Here you can see both the integrations are some integration limit of numerical values. So you can choose any one. Suppose if you choose this is x equals to 0 to pi by 2, so then this will be y equals to 0 to pi by 2. Or you can choose this one. You can choose this one, y equals to 0 to pi by 2, then this will be x equals to 0 to pi by 2. Okay, now here the first integration is dx, so obviously you can choose this is x equals to 0 to pi by 2, and the second one is dy, so this will be y equals to 0 to pi by 2. So first y equals to 0 to pi by 2, x equals to 0 to pi by 2 sine x plus y dx dy. So this is equals to, first integration is integration with respect to x, so y equals to 0 to pi by 2, integration of sine minus cos, so this will be minus cos of x plus y. Okay, and the integration limit is, this is the limit of x, so x equals to 0 to pi by 2 dy. Okay, you have to put x equals to 0 and pi by 2, so this is equals to integration 0 to pi by 2, so this will be minus cos of pi by 2 plus y minus upper limit minus lower limit, so this will be minus minus plus cos of 0 plus y dy. Okay, this is equals to, now integration with respect to y. So first integration, this portion, cos integration is sine, so this will be minus sine pi by 2 plus y. Okay, plus this will be sine y, and the integration limit is y equals to 0 to pi by 2. So you are getting minus sine pi by 2 plus pi by 2 plus sine pi by 2. this is upper limit, minus lower limit, so this will be minus minus plus sine pi by 2 plus 0 minus sine 0. Okay, so you are getting this is pi by 2 plus pi by 2, that means sine pi, and sine pi is equals to 0. This is sine pi by 2, so plus 1. This is sine pi by 2, so plus 1, and this is sine 0. Sine 0 means 0, so the answer is 2. Okay, now next question. Evaluate double integration over r y minus 2x dx dy. Okay, where r is equals to 1 less than equals to x less than equals to 2, and 3 less than equals to y less than equals to 5. Okay, so here the region R is given, where you have to find out the integration of this function. Solution. So here you can see that the region is, the boundary of x is from 1 to 2. Okay, if I draw the curve x equals to 1, that means a straight line parallel to y-axis at a distance 1, that means this one. Okay, x equals to 2, that means this one. Okay, y equals to 3, y equals to 3, let's say this is y equals to 3, and y equals to 5, let's say this is y equals to 5. So this one is y equals to 3, y equals to 5, this is x equals to 1, and x equals to 2. This is the region, and you have to find out, that means this region is your R. Okay, and you have to find out this integration in this region. Okay, so double integration. Now this is y minus 2x. I have told you that when you are taking the limit of x, the limit will be from left to right. So first let's take limit of x left to right. Now left to right means this straight line, this is the closed region now, this straight line from this straight line to this straight line, and we know this straight line is x equals to 1, and this one is x equals to 2, so limit will be x equals to 1 to 2. Okay, now for limit of y means down to up. Okay, so down curve is this one, y equals to 3, and upper curve is this one, y equals to 5. So y limit will be y equals to 3 to 5. Clear? Now just solve the equation. This is dx dy, so this is equals to y equals to 3 to 5. Now integration with respect to x. When you are integrating with respect to x, so all other variables other than x will be considered as constant. Here you have y, and integration is with respect to x, so this will be xy minus, this will be 2x square by 2, that means x square. Okay, and integration limit is 1 to 2 dy. So this is equals to, you have to put x equals to 2 and x equals to 1. So y equals to 3 to 5. So this is 2y minus 4 minus y plus 1 dy. This is equals to, so this will be y square minus, let's simplify first, y equals to 3 to 5, so 2y minus y, that means y minus 4 plus 1, that means minus 3 dy. So you are getting y square by 2 minus 3y. Okay, 3 to 5. So this is equals to 5 5 25 divided by 2 minus 15 minus 9 by 2 minus minus plus 9. Okay, and if you simplify this, (16 by 2 minus 6). Okay, so you are getting 8 minus 6, this is equals to 2. So 2 is the answer, okay, for this problem. But this was very easy problem. Now come to the next problem, which is very very important for your semester examination. Question: determine double integration over r x square plus y square dx dy. Okay, where r is the region bounded by y equals to x square, x equals to 2 and y equals to 1. Okay, so determine double integration over r x square plus y square dx dy, where what is r? R is the region bounded by these three curves. The region r is bounded by these three curves. Okay, what is the equation? Y equals to x square, obviously parabola above x axis. X equals to 2, that means a straight line parallel to y axis at distance 2, and y equals to 1, that means parallel to x axis at distance 1. Okay, so let's draw the figure. Let's say this is x axis and this one is y axis. We have to draw the figure only on the first coordinate. Okay, so y equals to x square, that means a parabola above x axis. Let's say this one. Okay, this one. Now x equals to 2. X equals to 2 means parallel to y axis at a distance 2. So let's say this one. This is x equals to 2 and this one is y equals to x square. Okay, and the last one is y is equals to 1. Y equals to 1 means let's this one, a straight line parallel to x axis at a distance 1. This curve is y is equals to 1. Okay, so what is the closed region? Here given na, the region bounded by these three curves. Bounded by means this region na, this one. Okay, and this is your region R. Clear? Now you have to find out the integration in this region capital R. Okay, so let's start. Solution. Double integration. Okay, x square plus y square dx dy. So first let's take the integration of x. Integration of x means left to right. So from this to this, left to right means this curve, this is the boundary, this curve to this curve. Yes or no? Left to right, that means the limit of x is equals to, this curve is y equals to x square. Y equals to x square. So what will be x? X equals to root y. Yes. So x equals to root y 2. What is the straight line? This one is x equals to 2. So x equals to root y 2, x equals to 2. Clear? Now y. Y means down to up. Down to up. Okay. Down means let's change the color. Let's take green. Okay, so down means this curve, okay, down to up. Up means actually this area na, our closed area, so this portion, actually up means this portion. We already have closed the region from left hand side. Okay, so the boundary, upper boundary is this portion. And what is the curve? Here the point, this point is x equals to this is x equals to 2, so obviously this point will be 2. Okay, so what will be the equation of the straight line? X equals to 2, yes or no? And the y curve is y starting from y equals to 1, and this point is x equals to 2. So if x equals to 2, and this is the point of intersection of y equals to x square and the straight line x equals to 2. I am repeating, this point, this is the point of intersection of y equals to x square and the straight line x equals to 2. So if I put x equals to 2, so you will get y equals to 4. That means this straight line, this is the straight line, and the equation is y equals to 4. Yes or no? That means a straight line parallel to x axis at a distance 4 from the x axis. Okay, so what will be the y limit? Y limit will be y equals to 1, this one. Okay, and this curve, y equals to 1 to 4. So y equals to 1 to 4. Now let's solve the equation. So this is equals to first integration with respect to x. So y equals to 1 to 4, integration with respect to x, so this will be x cube by 3 plus xy square, because when integration is with respect to x, y will be considered as constant. So x limit is root y to 2 dy, and this is equals to integration y equals to 1 to 4. 2 cube means 8, 8 by 3 plus 2y square minus lower limit, so this will be y root y. Yes or no? Root y to the power 3, that means y root y, or you can write y to the power 3 by 2 divided by 3 minus x means root y, so y square into root y, that means y to the power 2 plus half. 2 plus half means y to the power 5 by 2. Clear? Dy. So what you are getting, this is equals to let's integrate with respect to y. So this will be 8y by 3 plus 2y cube by 3 minus y to the power 3 by 2 plus 1, that means y to the power 5 by 2 divided by 3 into 5 by 2. Okay, minus y to the power 5 by 2 plus 1, that means 7 by 2 divided by 7 by 2, and the limit is 1 to 4. Okay, and if I simplify this, so we are getting 8y by 3 plus 2y cube by 3 minus this will be 2y to the power 5 by 2 divided by 15 minus 2y to the power 7 by 2 divided by 7, and this is equals to 1 to 4. Now upper limit minus lower limit, so this is equals to, so 8 into 4 32 by 3 plus 2y cube by 3, so 64 into 2, that means 128. So 128 by 3 minus 2 into 4 to the power 5 by 2, and actually 4 to the power 5 by 2 means 2 to the power 2, so 2 cancel, that means 2 to the power 5, and 2 to the power 5 means 32, and 32 into 2, that means 64, divided by 15, minus 2 into y to the power 7 by 2, that means 2 into 4 to the power 7 by 2, that means 2 to the power 2, so 2 cancel, that means 2 to the power 7. Okay, and 2 to the power 7 means 128, and 128 into 2, that means 264. Now 128 into 2, 256, 256 divided by 7, this is upper limit. Now minus lower limit. Lower limit means y equals to 1, so this will be 8 by 3 plus 2 by 3 minus 2 by 15 and 2 by minus 2 by 7. Now if you simplify this, just normal calculation, the result will be 1006 divided by 105. Okay, that will be your answer. Just simplify the problem. Okay, so let's solve another problem. Next question, evaluate double integration x square plus y square dx dy over the region bounded by xy equals to 1, y equals to 0, y equals to x, and x equals to 2. Okay, so first of all let's draw the curve. Okay, this is your region and the bounded by these 4 curves. Okay, now tell me what is xy equals to 1. This is rectangular hyperbola. Y equals to 0, that means x-axis. Y equals to x, that means a straight line passing through the origin making an angle 45 degree with the x-axis. And x equals to 2, that means a straight line parallel to y-axis at a distance 2 from the y-axis or from the origin. Okay, so this is x-axis, this is y-axis. First one is xy equals to 1, that means rectangular hyperbola, so this one xy equals to 1. Okay, next y equals to 0. Y equals to 0 means x-axis. Okay, y equals to x means a straight line passing through origin making an angle 45 degree, this one. Okay, y equals to x, and the last one is x equals to 2. X equals to 2 means, let's say this is the curve, x equals to 2. Okay, this is the figure, and the closed region is this one. This is the closed region. Okay, this is your region R where you have to find out the integration. Clear? So let's write this straight line. This is y equals to x, this is y equals to 0, and this one is x equals to 2. So solution, this is double integration. Let's say this origin is R, x square plus y square dx dy. Okay, now problem is, if we have to find out the limit of x, the process is left to right. Left means this curve. Okay, and right means this and this. Okay, that means when we are calculating the limit of x, we are getting two separate curves. Okay, and this is not possible. That's why we have to break the whole region into two parts. Let's say this is the, we are breaking the whole area or whole region into two parts at this point of intersection. Okay, this is the point of intersection of the two curves xy equals to 1 and y equals to x. Okay, now the left hand side area, let's say this is r1, right hand side is, let's say this is r2. So we have to calculate the integration over r1 dx dy and over r2 x square plus y square dx dy. Okay, problem is here we are getting three for x axis or for x limit, we are getting three separate curves. That's why we have to break the region. Okay, now this is equals to, now for the region r1, x limit is left to right, yes or no? X limit is left to right. So how you can take the x limit? So first, if I take the y limit is down to up. Down means y equals to 0 and up means this curve y equals to x. So we can take y equals to 0 to x. And left to right means from left hand side I can choose this curve, to right hand side that means this curve. Okay, so left to right means I can choose x equals to 0 to, and this point, what is the point? What is the point of intersection? This point. This is the point of intersection of xy equals to 1 and x equals to 1 y, these two curves. See, if I put y equals to x in this equation, we are getting x square equals to 1. That means x equals to plus minus 1. Minus 1 is not possible because this is the first coordinate. So x is equals to 1. So obviously y will be 1. That means this point is 1 comma 1. Okay, so obviously this curve will be x equals to 1 because parallel to y axis x equals to 1. So integration x equals to 0 to 1. Now question is, if you take the first limit for the limit of r1, the region r1, if you take the limit as x equals to y to x equals to 1. Okay, x equals to y to x equals to 1. Okay, and if you take y equals to 0 to y equals to let's take 0 to 1. If you take this limit, again the result will be same. Our aim is we have to cover the whole area. Okay, we have to cover the whole area. I have taken, this is the left boundary and this is the right boundary. Okay, and this is the lower boundary, this is upper boundary, and if you take the opposite in opposite direction, again you will get the same result. Okay, so now plus r2. Now for we have to calculate for r2. Okay. Okay, in r2 you can see this is the left boundary. Okay, left boundary means here the equation is x equals to 1 and this is the right boundary, that means x equals to 2. So you can choose x equals to 1 to 2. Okay, and upper lower to upper, this curve is y equals to 0 and this curve is xy equals to 1. So what will be y? Y is if xy equals to 1, so y is equals to 1 by x. So this will be y equals to 0 to 1 by x. Okay, x square plus y square dx dy x square plus y square dx dy. Now just simplify the problem. So this is equals to first integration y equals to 0 to x. So first integration is with respect to y, so obviously we have to change the order because this is the order dx dy. Okay, but the first integration is with respect to y, so we have to change the order. So this is equals to integration x equals to 0 to 1, integration y equals to 0 to x square plus y square dy dx plus x equals to 1 to 2, y equals to 0 to 1 by x. Again this is integration with respect to y, so we have to change the order, x square plus y square dy dx. Now first integration with respect to y, so integration x equals to 0 to 1, so this will be x square y plus y cube by 3, limit is 0 to x dx plus x equals to 1 to 2, x square y plus y cube by 3, and the limit is 0 to 1 by x dx. Okay, now put upper limit minus lower limit. So this is equals to integration x equals to 0 to 1 x cube plus x cube by 3 dx plus x equals to 1 to 2, this will be x plus 1 by 3x cube, 1 by 3x cube dx. Okay, now integrate this with respect to x, so you will get x to the power 4 divided by 4, or you can just simplify. First simplify this, x equals to 0 to 1, you are getting 4x cube by 3 dx plus integration 1 to 2 x plus 1 by 3x cube dx, x equals to 1 to 2, so this is equals to 4 by 3 common x cube, integration of x cube is x to the power 4 by 4. Okay, upper limit 0 to 1 plus this is x square by 2 minus 3 by minus 3 plus 1 divided by minus 3 plus 1 2, so this will be 1 by 6, so minus 1 by 6 x square 1 to 2, so this is equals to, here 4 cancelled, this 4 cancelled, so you are getting 1 by 3 into 1 minus 0 plus 2 into 2 4 by 2, that means 2 minus divided by 4 24 minus 1 by 2 plus 1 by 6. Okay, so what you are getting, 1 by 3 plus 2 minus 1 by 24 minus half plus 1 by 6. LCM is 24, so this will be 8 plus 48 minus 1 minus 12 plus 4, and this is equals to 47 divided by 24, and this question is very important. Okay, so I already have told you in my starting of the lecture that there are some important points you have to remember. Okay, so I think this lecture will be very beneficial for you. Okay, now practice all your questions from textbooks and question banks. Okay, thank you.